Hey everybody. Uh so I'm gonna do something that came out of the office hours that I held over spring break because of how evil I am. I am very evil, and I dared to offer some time to meet over Zoom. Anyway, um, there are some questions in chapter 6 that might be a little weird, so I want you guys to remember we've talked about this before. This textbook really likes to do stuff like this. They had a variable that followed a uniform curve. It'll say x, this little squiggly, you can think of it as follows a uniform distribution, and let's say it goes from 7 to 11. So that would be from 7 to 11, uniform curve. I can figure out the height, blah, blah, blah. But what's important is it's uniform, so they put a U there. Wow. Then it's the first number and the last number. So it goes uniform from 7 to 11, figure out the height's 1/4, then I could do all that kind of business. Okay. If I had a binomial, I would put a B there. That's crazy. And the two most important things to know for a binomial situation is N and P. So whatever N is and whatever the probability of success is. I don't need to be told what Q is, because if I know what P is, I can figure out what Q is. And then finally, the one that's important for chapter 6, if I have a normal curve, guess what? Holy shit, I use an N. That's amazing. So if you see X tilde blank, parenthesis, blank, comma, blank. All right, so you have to be able to tell. Is it a uniform thing I'm dealing with? Is it binomial thing I'm dealing with? Is it a normal curve I'm dealing with? And then the two most important things, of course, for a normal curve, for calculating probabilities, is the mean and the standard deviation, so I can make z-scores. Okay, so there are problems that ask you, the problem looks like this, x tilde blank, parenthesis, blank, comma, blank, like that, okay? And this is not a little sleeping dude, no. So now you know what to put here. B-U-N, bun. Which one of them? And then the two most important things. All right, so you can pause if you want to, and we're done. All right. So let's look at a couple real quick specific ones. I want to remind you about a few formulas that we know. So we definitely know this bad boy. We've been using this a lot back in the day, PC, pre-COVID. Then we have this, we solved it for X, and we got this little dude, which is actually the definition almost, or not almost, it is actually exactly the definition of z-score. Z-score is the number of standard deviations from the mean to the data point. Bam. All right, I'm getting my stuff all mixed up. So there's a problem that says, let's see. For example, problem says something like this. X follows normal curve, and then it puts a 7 here and a 3 here. What value of X has a z-score of 2? Right, so there's some problems in the homework that look a lot like this. Well, what do I know? I know the mean, I know the standard deviation, I know the z-score. Can I figure out what X is? Yeah, I can. I start at the mean, and you go 2 of these. So the score that has, the raw score that has an X value of 2 is 13. That's 2 steps above the mean. Okay, so those kind of problems, that's the problems like 12 through 20 or so. Okay, so you can pause there if you want to. All right. Then I had a question, let's see, postpone, let me pause. Yeah, here we go. For example, number 64 is the one about blood pressure. Part A has to be easy. They ask you for a Z-score for 100 and 150. So you know the formula. They tell you this. They tell you this. They want it for 100 and 150. So you just do this twice. Yeah. Part B says a male friend of yours said he thought his systolic blood pressure was 2.5 standard deviations below the mean. So he thinks that his Z-score is negative 2.5. So you can figure out what his blood pressure reading would be then. You can change that Z-score. That's how many steps away from the mean that he thinks his value is. You can convert it into an actual value. This many, so negative 2.5, put the standard deviation in, put the mean in, do the work, and then you can compare it to what he thinks that means. He thinks it means he's between 100 and 150, which you can very easily see after you do this that that's wrong. The X will not be between 100 and 150. 63 is exactly like this, talking about NBA players' heights. Let me think. Okay, so that's what came out of the office hours. I'm going to have some more, tomorrow. As you can tell, I'm really changing what I think the setup is going to be almost daily. My poor little tripod for my camera had a leg break off, so I'm trying to, this seems to work pretty well. You guys can't see what I've got going on here, but it's funny to me, but it seems to work pretty well. I'm working on updating the syllabus, so I'm going to send that out. I don't know why I'm saying all of this. I'm just going to send an email out with all the stuff. So let me know if you have issues. Keep up with your email. Try to attend the Zoom stuff this week. You don't have to. You definitely have to, starting Monday, attend something. I'm going to send you out more specific information about how things are going to work, how I'm going to count attendance, stuff like that. And of course, the same old rule applies. If you miss too many classes, I can drop you, as always. So you want to be careful about that. So if you really want to stay in this class and try to get a grade for the semester, it is a class. You still must attend. You still must do the work, all of this. So I'm working on updating the syllabus so I can send it out to everybody, so you know how it's going to kind of work now in this new structure that we've been forced into. I love how some of the responses on the survey I did make it seem as if I want this way of things. That is so very desperately not true. I don't want any of this. But this is the only way to continue to try to get you through this course. You obviously need this course for something. That's what I'm here to do, is to help you get through this and learn the material so you can do whatever it is you want to do. Anyway, enough of that. I'll post this and I'll let you guys know. See you later.